Problem 21. Anne, Ben, Catherine, David, Ella, and Fred, in that order, are standing in line for a candy at the fair. The clown that is giving away the candy does it in the following way. Sends the child in front of the line to the end of the line, then gives candy to the child in front of the line, then sends the child in front of the line to the end of the line, then gives candy to the child in front of the line, etc. Until all children get candy. Which of the following is true? These are our options. Let's write the children in order. So we have Anne, Ben, Catherine, David, Ella, Fred. Move Anne to the back and Ben gets the candy. Now Catherine comes in first. Now move Catherine to the back and David gets candy. Now Ella comes at first. Move Ella to the back, Fred gets candy. And continue the same way. The candy order would be Ben, David, Fred, Catherine, and Ella. So Catherine gets candy after David. So our option, Catherine gets candy after David, is true. So our answer is D. Problem 22. 3 small squares are drawn inside a larger square as shown. What is the length of the line marked with the question mark? This is what we have to find, and these are our options. The large square has a side length of 28 centimeter. That means this is 28 centimeter. The small square has a height that would be 6 centimeter because 28 minus 22 gives us 6 centimeter. Similarly, this is 28 centimeter. So the side length of this square would be 13 centimeter because 28 minus 15 gives us 13 centimeter. The side length on the top is 28. So in total 6 and 13. That should be subtracted from 28. So 28 minus 6 minus 13 gives us 9 centimeter. So we got 9 centimeter for this square. Now we know the side length of the square is 9 centimeter. So 28 minus 9 gives us 19 centimeter. So the question mark indicates 19 centimeter. That is, our answer is option E, 19 centimeter. Problem 23. Steffi took a square piece of paper and folded one vertex to the center of the square. Next, he folded the paper along the symmetry axis of the figure. Along the symmetry axis of the figure, and that becomes this. And it obtains a quadrilateral. What is the measure of the quadrilateral's largest angle? These are our options. Now let us build up the figure which we have been folded. So it would look like this. First, the diagonal makes a 45 degree with the top side. So this is a 90 degree and it makes it a 45 degree. This makes it a 90 degree. That means the inside angle, this one is 45 degree. The largest angle, this is completely 180. So 180 minus 45 gives us 135 degree. So the largest angle of the quadrilateral is 135 degree. So our answer is option A, 135. Problem 24. 3 positive integers have product 12. Repetition of the factors is allowed. Which of the following numbers could not be the sum of the 3 integers? We need 3 whole numbers whose product is 12. Let's list all the possibilities. So we have factors 1, 12, 2, 6, 3, 4. These are the 12 factor pairs. So we can write repetitions allowed. We can write 1, 1, 12, because we need 3 positive numbers. So 1, 2, 6, 1, 3, 4, and also 2, 2, 3 is possible. The sum of these numbers would be 14, 9, 8, and 7. So the possible sums are 7, 8, 9, and 14. So 12 is missing. So our answer is option D, 12. Problem 25. Mary put the same amount of liquid in 3 rectangular vessels. Viewed from the front, they seem to have the same size, but the liquid has risen to different levels in the 3 vessels. Which of the following images represents the 3 vessels when viewed from above? So all the 3 vessels have the same amount of liquid, but they seem to have risen to different levels in 3 vessels. Now let's look at them from the top. If a vessel is narrower, the liquid rises higher. If a vessel is wider, the liquid stays lower. So vessel 2 is the narrowest because it has the highest liquid level. Vessel 3 is the widest because it has the lowest liquid level. Vessel 1 is in between. So only option A matches these widths. So our answer is option A. Problem 26. There are 8 cards with digits 1, 2, 3 to 8. 2 boys and 2 girls sit in some order around a table. Starting from one of them and going clockwise, they take one of the cards and put them from left to right. The boys want the final number to be as large as possible, and the girls want to be as small as possible. Which of the following numbers cannot be the final number? These are our options. Let us expand these numbers. So it views as option 1 has 8, 1, 7, 2, 6, 3, 5, 4. The possible sitting patterns for it is the boys takes the largest digit and the girls takes the smallest. So we have boy, girl, boy, girl pattern. Boy, girl, pattern. For option B, the girls takes the smallest digit. So we have girl, girl, boy, boy, girl, girl, boy, boy. For option C, we have girl, boy pattern and boy, girl, girl, boy, boy and girl pattern. For option D, we have boy, girl, girl, boy, boy, and that is supposed to be girl, but it is 4. So that could be our answer. The pattern for the 5th option is girl, boy, girl, boy, girl, boy, girl, boy. So this needs to be replaced. So it should be 4 to be 3 and 3 to be 4. So our answer is option D. Problem 27. A rafter takes people across the Avro River, doubling everyone's money in their pocket during the trip. One trip costs 24 coins and you pay at the end of the trip. Alfonso went across the river 3 times. Unfortunately, after paying for the last trip, he had no coins left in his pocket. How many coins did Alfonso have before the first trip? These are our options. For this problem, let's work backwards. After paying for the last trip, Alfonso had 0 coins. So before paying 24 coins, he must have had 24 coins. Since the rafter doubles the money first, before the 3rd trip, he had 12 coins. Now repeat the same steps. So before paying, he had 12 plus 24 coins, that is 36 coins. So before 2nd trip, he had 36 divided by 2 gives you 18 coins. One more time. Before paying, he had 18 plus 24 coins, that is 42 coins in total. So before the first trip, he had 42 divided by 2 gives us 21 coins. So he had 21 coins. So our answer is option D. Problem 28. Vadim has a square pieces of paper divided into 9 cells. He folds the paper as shown, overlapping horizontally and then vertically so that the gray square ends on top. Vadim wants to write the numbers from 1 to 9 into the cells so that once the paper is folded, the number would be in increasing order with number 1 on the top layer. What number should he write instead of A, B, and C? These are our options. First, fold the paper horizontally, then fold it vertically. So you write the number 1 in here. When you fold in vertically, you would know that the number 1, 2, 3 would come here. The number 4, the back side of it would be just behind here. So that would be number 4 here, 5 here, and 6 here. The number 7, when we fold it, it would be 7, 8, and 9. You can try folding the paper. So our answer is A is 6, B is 4, and C is 8. Problem 29. Don builds a pyramid with balls. The square base consists of 3 by 3 balls. The middle layer is 2 by 2 ball and there is 1 ball at the top. There is a glue at each contact point between the 2 balls. How many glue points are there? These are our options. Let's count the glue point layer by layer. First, look at the bottom layer with 9 balls. So each ball touches its neighboring point. So we have the glue point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that gives 12 glue points in the bottom layer. Now add 4 balls on the top. So each orange ball touches 2 corner balls and the 2 neighboring orange balls. So we have 1, 2, 3, 4, plus each ball contacts the bottom layer. 1, 2, 3, 4. So we have 4 contact in here with 1 ball. So that is 16 by each orange ball plus 4 with its neighboring. So it causes 20. The bottom layer has 12 glue points. The top layer touches from 4 points. So the top layer has 4 glue points. So total is 36, which forms problem 30. The figure shows a map of some islands and how they are connected by bridges. A postman has to visit each island exactly once. He starts on the island marked start and would like to finish on the island marked finish. He has just reached the black island at the center of the map. In which direction should he move to be able to complete his route? The route is split into 2 parts. So he will start from here. He goes up, he goes up, goes up, and he reaches to the black point. Now to cover entire island, if he moves in this direction and reaches to this, he will be able to cover all the islands. So this means he needs to move in an east direction. So that means by going east, he is able to complete his entire route. So with this, we end the problem set for Math Kangaroo 2020 Part C.